Yes, guys, today we've got question 1 from 2010 step 1 paper. So we're given an equation and we need to find the values of a, b, c and d. So that's this part here. So with this sort of equation, got loads of different variables: x squared, y squared, xy, 4x, x and y. Now what we need to do is expand the right hand side and compare coefficients, and then hopefully form equations for a, b, c and d. So let's go. So if we're expanding the right hand side, we have x squared plus y squared, and then there'll be an xy term, so that will be xy, that'll be minus 2xy, and then we'll have an x term which will be plus 4x, 2 times x, and then that happens twice, and then for the y we'll have minus 4y, and then for the 2 we'll have just 2 squared, so that's 4, and then for the second bracket we'll have c squared x squared plus 2c xy plus y squared and plus d. Now we need to group all of our terms together, so let's group the x squared first. So for x squared we have a plus bc squared x squared tick tick. Y squared, well, we've just got ay squared and 2cxy, so that's a plus 2cx. Actually no, that's a mistake. We should be looking here, y squared here, and there's a b on the outside, so we have a plus b y squared, so that's the y squared done. Onto the xy, so we have minus 2ax and plus 2bc. Right, so let's write the 2bc first. 2bc minus 2a and x, y. So that's tick, tick. What we're left with just x, y is an constant. So we have a 4a x, then we've got a minus 4, let's bracket that off, y, and then we've got a plus 4a plus d. Now that we've sorted everything in terms of these variables, we just need to compare. So a plus bc squared equals 5, a plus b equals 2, 2bc minus 2a equals minus 6, but we can just divide through by 2. We have bc minus a equals minus 3. 4a equals 4, so that means a equals 1. Let's just write that here on the side. And then 4a plus d equals 0. So 4a plus d equals 0. Now if we take that 4a plus d equals 0, we'll have 4 times 1 plus d equals 0, therefore d equals minus 4. Let's put that up here, right there. And then our b term, and obviously just be 1, b equals 1. So what we're looking for now, just our c term. So we can just look at this equation here. This looks fairly easy to deal with. bc minus a equals minus 3. Sub in the known values for b and a. So we have c minus 1 equals minus 3, so c equals minus 2. Now that we've got our values for a, b, c and d, we can just sub them in. Actually, don't even need to sub them in. We can just put a box around it, and that's our first part done. Now for part 2, solve the simultaneous equations. Well, with this, I'm obliged to think that this in its factored form will have a similar format to the first equation. Reason being is that will probably allow us to cancel quite nicely. So let's check. So we know the expanded form of right hand side here. Well, we've just got all that, we've just expanded that. So let's drop that down actually and compare with our second equation. So let's see, we've got 6 is equal to a plus bc squared. And then a plus b equals 3. Then we have minus 8 as 2bc minus 2a. So we can say bc minus a equals, that was minus 8, so that becomes minus 4. 4a equals 8, therefore a equals 2. Just write down the side. And then 4a plus d equals, well, let's just say, well, if we're just looking at this part here without the right hand side, we can say 4a plus d equals nothing. So 4a plus d equals 0, and we know a to be 2, so 4a is 8, d equals minus 8, so let's put that here. A plus b equals 3, meaning b must equal 1. And then if we look at our, what are we looking for? C. So C, well, we know bc minus a equals minus 4. So c minus 2 equals minus 4, which implies that c equals minus 2. So we have 2, 1, minus 2, and 8. Pretty similar because to the first part where b and c were 1 and minus 2 respectively. So now that we've found these values for a, b, c, and d, let's write our equations out in this form. A x minus 1 plus 2 squared plus b plus d. So if I copy the question down, nope, right. First equation, a is 1, 1 minus 2 minus 4. So we have x minus 1 plus 2 squared. Our b value is 1. That's plus y minus 2x squared. And the d term was simply minus 4. And this equals 9. So let's write this as equal to 13. And then similarly below, see the same thing. A was, I believe, 2. That's right. 2x minus y plus 2 squared. Then b was 1, c was minus 2, d was minus 8. So we have, b was, this would have been, again, y minus 2x squared. And then plus d was minus 8, so minus 8 plus 14. And minus 8 equals 14. Let's take that minus 8 over to become 22. Now we just have to solve these two simultaneously. Notice how both equations share these two terms. So let's say, well, let's let a equals x minus y plus 2 squared, and then b equal y minus 2x. So we have a plus b equals 13. We have 2a plus b equals 22. Let's subtract. So we have minus a equals b cancelled, 13 minus 22 is just minus 9, so therefore a equals 9, meaning b must equal 4. Now notice these are square numbers, which is quite useful. because, oops, shouldn't squared there. A and B are both square numbers. You can say are square equations. So let's replace A and B with what we sub them in as. So equals 9, and then we said B equals Y, y minus 2x squared equals 4. Now if you square root to get to just have a x minus 1 plus 2, so if x minus 1 plus 2 equals plus or minus 3, similarly on the right hand side we've got y minus 2x equals plus or minus 2. So we've got a few possible values of x and y. I believe there's 4 pairs because we can solve the positive here and the positive here, positive, negative, 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 or negative, positive. That's 4 ways. So let's take the positive. So what's equation 1, equation 2. Let's do these. So equation 1 is positive, and equation 2 is also positive. So if x minus 1 plus 2 equals 3, so x minus 1 equals 1, and for equation 2 we have y minus 2x equals 2. Well, we can just add these so we can cancel the y terms. So we have minus x equals 3, therefore x equals negative 3, and if x equals negative 3, then y would equal minus 3 add 4, y would equal 4. So that's one pair of solutions. Let me just check that works in our second equation here. 4 minus, that actually doesn't work. What have we done wrong here? X minus 2x minus x, 1 plus 2 is 3, and we done everything right above, I believe so. Minus 2x equals 2, so if x, that is a mistake, y should be minus 4. So minus 3 minus minus 4 equals minus 3 plus 4, which is 1. Y minus 2x, so minus 4 minus 2 times minus 3, so plus 6 equals 2. That is our first pair of solutions. Got 3 more cases to deal with, so let's take a case where the first equation is positive and our second is negative. It should be easy. X minus 1 equals minus 5, y minus 2x, actually what have I done there? No, sorry, x minus y equals 1, y minus 2x equals negative 2. Again, let's add these equations. Forces our y term to cancel, so we have minus x equal minus 1, therefore x equals 1, and then y must equal 0. And if you put that into our second equation, y 0, 0 minus 2, 1, so 0 minus 2 is indeed minus 2, so that works. Third case, gosh, it's getting long. Now we've dealt with all the cases when equation 1 is positive, and let's look at negative. So then we take 2 as positive. So we have x minus y equals minus 1. Is that right? No, because it should be actually minus 5. Then y minus 2x equals 2. Now if we just simply add these, minus x equals minus 3, x equals 3, and therefore y equals minus 8. Let's check, is that right? So 3 minus, should be positive 8. That should do it. 3 and 8, that seems right. Now, last case, let's just shrink this all. So we have when both our equations are negative. So we have x minus y equals minus 5. Y minus 2x equals negative 2. So let's just sum these. So we have minus x equals minus 7, x equals 7. Therefore y equals 12. Let's put a box around these equations. And let's check if that works. 12 minus 2 times 7 is 14. And yeah, that seems right. So that's it for this question. We've got our pair of solutions that solve these simultaneous equations. Not too bad for a step question. I mean, it was question 1, but we'll take it. So see you in the next step video. Goodbye.